Today we're going to take a look at the use of the Omni load tester. Why would we use it? Well, we're going to use it to quickly test for degradation in the wiring or the connections or under torque of terminals, unseated pins. And the main issue is something like this. This is, I'm representing a motor or a light or a starter, anything where I need not only the voltage. Voltage is one half of the problem, but current. If current is decreased, and you look at this light, and is this full brightness? Is this at the best that the wiring, the connector delivery can do? I can't tell. My eyes are not calibrated. In fact, if you look at this light, and if I use a load light to test, which I don't recommend because a load light, because it's an inductive load, creates a kick and it can actually damage relay contacts, switch contacts. And if you use this on the output of an LRU, like a computer, you would blow that computer, right? It's a 40 milliamp load, and many of those circuits in the LRU are only 2 milliamps. Last thing you want to do is destroy a $1 million computer. So using a load lamp, that's what we used to do in the old days. We would see the light, hey, it's on. I would assume this circuit's good. Bad assumption. A lot of times you're gonna have intermittent issues like this. You'll see that right now I have 470 ohms of resistance in series from my power supply into, I can have a meter or a motor or a lamp. Right now I have a lamp here. And 470 ohms right now is, you can't tell. And this is a flight deck effect. 300 ohms is a hard flight deck effect. 100 ohms in series is typically a hard flight deck effect for something like flight controls, where 20 ohms is very highly intermittent, even an ohm. If I remove the 470 ohm resistance in series, you'll see on the light, it's bright. But would you be able to tell just using a load lamp if that circuit's good? No, absolutely. This would be a hard fault. So how can I do that? Well, we created this device. So we could have objective testing, non-subjective, right? We don't want subjective tests where I'm using calibrated eyeball. All I'm gonna simply do is disconnect the lamp and just demonstrate quickly the problem with the multimeter. Because you could be saying, Mike, I could absolutely detect that 470 ohms in series, a hard fault. I have a hard fault. The FIM, the fault isolation manual, says remove the connector and let's check for power. Well, what's it say? It says 29.955 volts. I would assume that's good. I would say replace the lamp, replace the motor, replace the starter, whatever, because I have voltage delivery. But what it doesn't tell you is, do you have current? Do you have enough current to drive that motor, to turn that lamp on to full brightness? If I remove the 470 ohms, you see? What? You just see a slight change, not even a millivolt change. A millivolt, because remember, 470 ohms compared to the 10 mega ohm resistance within a high impedance meter. This is a TPI WA2025 advanced meter, but the Fluke, Simpson, an analog meter, you might see a little deflection on the needle, but you don't have enough load. So what we developed was just an attachment. I can take this attachment, I can unplug here, and you're just gonna connect it like you would. This works on any type of meter. It doesn't have to be a TPI. This is a WA2000 Omni load tester, and you simply select one of the three voltages you need. This is a 30 volt circuit, so I'm gonna put it on 30, but if it were 12 volts, I'd use 12. If it's 115 volts AC, I would go move it here. Each position uses a 10 milliamp load. That is critical. That means I can test not only a 115 volt power delivery circuit, but I can also test the output, like a 12 volt DC output of an LRU, without fearing of blowing it up. It's only 10 milliamps. Not only is it safe for the airplane or for your vehicle or whatever you're testing, machine. It's also safe for the meter. This is protected with resettable fuses, PTCs. Resettable fuses, so I cannot blow this up and I cannot blow the aircraft up. That's very good to know. So now all I'm going to do is connect like I normally would, right? I attach this, I select voltage. Let me turn that backlight on. And you're going to get your standard reading because I'm not loaded, I'm unloaded. So if I go to 30 volts DC and I hit this load, you'll notice I see a drop. I see a drop and it's very insignificant because it's only 10 milliamps. However, you'll see in the fault isolation manual and the AMM, the aircraft maintenance manual, will tell you select relative percent. And there's puts a little percentage symbol, and we tell you never break 0.5%. Typically on a good aircraft, it's 0. When I go between unloaded and load, it's typically 0%, right? And I do not have a fault here. So right now, I have a healthy airplane, 0.08%, tells me it's good. Now let's put in that 470 ohms of resistance. Now when I do that and I load, I see a 2.862 volt drop and I see 9.55%. You never want to break half. This is nearly 10% deviation when I have a fault. I'll remove the fault and you can see, oh, look at, now I'm healthy again. 0.02. So it's objective and makes it very quickly to see I have a problem there. Now I remove the fault and now let's try less resistance. You're like, yeah, sure, that's simple, 470 ohms. Well, let's try 300 ohms. So I put in my fault box, 300 ohms. As you can see, I don't have a change here, but when I load test it, again, 9%. Easy to see, 2.6 volt drop, 9%. I broke that 0.5% deviation. Let's try 100 ohms. 100 ohms. I'm down to 3.22%, 0.9 volt drop, but that again failed. Let's try 23 ohms. Can we detect that? That's very difficult. I wouldn't have a flight deck effect, but it would be highly intermittent. And now I'm 0.82%, so I still broke that 0.5%. Remember, when I tell you, when I turn this off and I hit this again, 0.08 on, this is 70 feet of 737 Jurassic wiring, removed from a 737-300. It's ancient. This wiring's 30 some years old, beat up, a lot of different connections, and yet, hey, I'm still healthy. I can still deliver a healthy amount of power. Again, 0.5% is bad. Really easy to test, really easy to connect. And that's it.